Picture this: handing an AI your company's entire codebase, dozens of books, or a lifetime of notes, all at once, and getting a real answer back. Giving an AI more context has long been a dream, but there was a hard wall in the way. The longer the context, the more the cost exploded. In May 2026, a startup claims it broke that wall. Its name is SubQ. Today, we look at what it actually claims and how far that claim should be trusted. SubQ is a large language model released on May 5, 2026, by a Miami startup called Sub-quadratic. The company's name is the core claim, sub-quadratic, meaning it costs less than quadratic. The headline is a native 12 million token context window. Next to the few 100,000 tokens typical models handle, that's a different order of magnitude. The company says it raised $29 million and gathered researchers from Meta, Google, Oxford, and Cambridge. There are 3 products: a full context API, a coding tool called SubQ code that reads an entire repository, and a deep research tool. To understand SubQ, you first have to know why long context is hard. At the heart of nearly every modern language model is the transformer, and inside it, attention. Attention makes every word in a sentence look at every other word. With n words, that's n times n relationships. So double the input and computation quadruples. 10 times the input, 100 times the cost. That's O of n squared, the quadratic wall. So expanding the context window was always expensive, and the industry built workarounds. RAG, which retrieves only a slice; chunking, which splits documents up; multi-agent splitting. All of them just ways to dodge the quadratic wall. SubQ's answer is SSA, sub-quadratic selective attention. The starting observation is this: a model computes every pair of word relationships, but only a tiny fraction of them actually carry meaning. It's like reading a book. You don't compare every sentence to every other sentence. So you compute only the relationships that matter. Through this selection, SSA claims it makes cost nearly linear instead of quadratic. Cost rises only gently as context grows. The company says this structure is how it cut attention compute by about 1,000 times at 12 million tokens. But one thing to flag: sub-quadratic attempts themselves aren't new. State space models and linear attention have been around for years. The reason they never replaced the transformer? They gained efficiency but lost on quality. SubQ's numbers are genuinely impressive. The word to stress is claimed. These are all the company's own figures. 52 times faster than standard attention at 1 million token length. At 12 million tokens, 92.1% accuracy at pinpointing information. On the long context benchmark ruler, 95% accuracy for just $8, where Claude Opus purportedly costs around $2,600 for a comparable score. A cost gap of hundreds of times. If these numbers are real, this isn't a mere improvement, it's a game changer. Here's the part that matters most. Every number you just heard has not yet been independently verified. Within hours of SubQ's release, the AI research community split in two. One commentator summed it up: either the biggest breakthrough since the transformer, or AI's Theranos. Researchers, in one voice, demanded independent reproduction. The skepticism has grounds. First, listing both efficiency and quality by 1,000-fold at once is exceptional in the history of AI. Second, as we said, sub-quadratic architectures have always hit a wall on quality. Third, no third party has reproduced the results yet. A startup's own announcement and verified scientific fact are not the same thing. So if you want to check it for yourself, how? First, know this. SubQ is not open source. The model weights aren't public, and the company says it has no plans to release them. You don't run it on your own machine, only through an API. Access is private beta. You request early access at subq.ai, and they open it up in order. There are 3 products: the full context SubQ API for developers and enterprise teams, SubQ Code, a command line coding agent that loads an entire repository into one context to plan, execute, and review in a single pass, and SubQ Search, which does deep research at chatbot speed. But here too, an honest note. What you actually get when you apply is SubQ 1M, Preview, a context of 1 million tokens. The headline 12 million is still a research stage figure. So using SubQ today means using 1 million, not 12. Go in knowing that. To wrap up, what held long context AI back was the quadratic wall. SubQ's answer shrinks to a single sentence. Don't look at every relationship. Pick only the ones that matter. That choice, they say, turned cost from quadratic into linear. If true, it changes the game for long context AI. But all we hold right now is the company's announcement. No independent reproduction, no peer review. Not yet. So when you look at SubQ, one question is enough. Who outside the company has reproduced the same numbers? Between hype and cynicism, the right answer is to watch. Whether the 1 million preview reaches 12, whether outside benchmarks reproduce those numbers. The moment it clears that gate, SubQ turns from a claim into a fact. Until then, an interesting claim and exactly that much.